everybody, welcome. Today we are going to get quantitative. I once heard a nature journaler say that I wouldn't want to use numbers in my nature journal because they just take all the magic and life out of things. And what it really made me think about is, isn't it sad that the way that that person was taught mathematics squeezed all the life and beauty and joy out of playing with numbers for that person?
Yeah.
You know, numbers are a language for describing the world, just as words are, and just as drawings are. And, you know, if you said, I wouldn't want to use a picture to describe the world because it just makes everything kind of look, if you had a bad experience with drawing pictures, you would be adverse to drawing in your nature journal. And it's the same thing with numbers. But just as with drawing or with writing, when you've got a bigger toolkit, there's more stuff that you can do with it, and it's a lot more fun. Math is not something that that's not, the idea that there are math people and non-math people has more to do with how we were exposed to mathematics than anything that is a predisposition for mathematics or not mathematics. Joe Bowler at Stanford has done incredible work looking at how basically all kids, if you expose to them to mathematics and with a growth mindset and ways that aren't just trying to like grind people down by relentless calculation, it's something that we can all do. And also there's lots of mathematicians who aren't good at calculating. So a lot of people think of math just as calculating, but it's thinking with numbers. So I just want to, let's start off with me showing you folks a few of the tools that I think allow us initially to find more numbers around us, and see if anybody has suggestions for other tools. If so, I will steal them. And then let's drop into our sort of free-flowing conversation about this. Let me jump over to my document camera. And show you the back pages of my journal here. So these are some quantification tools, and just physical things that you can put in a journal that help you find numbers. So one is just simply a ruler. And if you don't have a ruler, then you can measure something by how many forearm lengths, how many cubits something is, or how many sketchbooks something is tall, or how many acorns something is long. But for communicating lengths to other people, a ruler is really useful. So I have metric and imperial rulers in this journal. And what I really recommend people do is to adopt the metric. Once you get used to it, it is so much easier. Because if you think about, if you think about, the imperial system, you have units that are in 16ths, that are then in units of 12, that are then in units of 3. And so moving around between those, it really scrambles your head. So if something is 236 inches, what does that mean in feet? It's, that's not good. But with metric, you move the decimal point, and that is brilliant. Something that I recommend people get, oh, look, we're upside down. Ha. Something that I recommend people get is a retractable measuring tape. These are really fun, and when kids first get them, they get to go, that's really cool, right? Oh, that is fun. And so on here, it's got inches and metric on the other side. I do want to send a special shout out to the decimeter. So you've got millimeters, centimeters, and then for some reason when we think about these things, everybody jumps to and meters. And what you leave out is that if you're going up in groups of 10, between the meter and the centimeter is the decimeter. And so the decimeter is 10 centimeters, so a decimeter is about this long. And the reason that you want to have this is that there will be one of these units, millimeter, centimeter, decimeter, meter, that is going to be the best unit of measurement for whatever it is that you're looking at, or kilometer. So if you have that in there, when you're looking at something, you'd say to yourself like, ooh, these bushes would probably best measured in decimeters. For some reason, everybody skips decimeters in thinking about something. And so you think like kind of where your sort of margin of error, where you're going to be seeing kind of the different sort of interesting differences. It's not going to be at the meter level when you're measuring the heights of bushes. It's not going to be at the centimeter level. That's too granular to be really useful. It's going to probably be at the decimeter level. Is it this much higher or this much higher? We're now talking, decimeter sorts of things. So just include decimeter in your kind of measurement thinking. Let's jump back down to this. So here's a cool thing that you can do for measuring things along the ground. You can, if you learn your pace, that will be, that's good. Your pace is when you're taking steps, how many steps does it take you to go a certain distance? And so what you want to do is make a little racetrack for yourself where you measure out, let's say 50 meters, and then you find out how many steps it takes you to go 50 meters. And then you divide to get, you can get your meters per step or your steps per meter. And then what you can come up with is that for me, when I take one step, that is 0.82 of a meter. And for me, 1 meter is 1.22 steps. So once I've calculated my my pace, I can get those two numbers. And then if I want to go, say, 10 meters, well, that's 12.2 steps. If I take 100 steps and want to find out how far I went, I multiply 100 by 0.82. So those are really, really kind of useful things to have. That allows you to then measure distances walking around, and that is that's very cool. And another thing that you can do with that is if you look out and you want to measure a tree, hold your walk out away from the tree and hold your pencil out at such an angle that the top of the tree is at the top of your pencil. You put your thumb at the bottom of where you see the tree, and you turn your hand sideways, just as if you had taken that tree and cut it down, and it's now laying along the ground. And you look at what object on the ground is here, or you can have a friend walk out to that point. And Then you can measure that distance using your pace along the ground. You can find out how high an object is. In the Nature Journal Club here, we've talked also a little bit about degrees of arc in the sky. When we were doing the solstice activity, we used the 1 potato, 2 potato method. So if you're not familiar with that, the 1 potato, 2 potato method is that you stand, there's 360 degrees of arc all the way around you, right? Or around this way. And if I'm trying to see how high something is in the sky, I can figure out the degrees of arc of how far that is. That one easy way to do that is the 1 potato, 2 potato method, where what I do is I'm going to hold my hand up where the bottom of it is just at my eye level. And where I now sight off the top of my hand, that's 10 degrees of arc in this 360 degree going up into the air. So it's 10, 20, 30, 40, 50, 60, 70. If you get to 90 is straight above you, right? So this method is great. You can also, if you have your arm out at arm's length like this is 1 degree, this is 5 degrees, the fist is 10, this is 15, rock on, and shaka is 25. So if you want to go faster, you can go 50 degrees. All right, that's about 50 degrees. So you can use that to figure out when you see like sundogs on either side of the sun, how many degrees of arc are those sundogs from the sun, right? When you see a rainbow, how many degrees of arc high in the sky is that rainbow, right? So for measuring things in the sky plane, distances of stars to each other, how high is the sun above the horizon, all that sort of stuff, you need those degrees of arc. So another cool place to find numbers. A protractor is great. Measuring angles. You can measure angles. So this is in here, the way you would use this is you would hold this up to the tree and say oh, those branches are coming out at approximately this angle. A better way of doing that is if you have a goniometer. This is a goniometer, and it's used by physiotherapists to measure how much mobility you have in your shoulder. I damaged my shoulder, and so my left shoulder doesn't move as well as my right. And they use one of these things and they're figuring out like, ooh, this is messed up. So you can also use this. Let's say you can hold this up to the tree and look at the angle of something. Other things that I've done with it is I pointed one end at a duck that was reflecting green iridescence, and I pointed the other one at the sun. And then I was able to figure out the angle at which mallard head iridescence changed from green to purple by watching mallards swim around and tracking them. Or they keep this one, say, pointed at the sun. This one's going to track the duck. Oh, right in there is where the change happens. And I can read that off right here. That is at 80 degrees. Right, so it's a really useful way of measuring angle. So you can get these online. We'll pretty soon have goniometers also for sale in my store. Beaufort wind scale is really cool. It's a way of estimating wind speed, looking at physical phenomena around you. The scale originally went up to 12 for hurricane force winds. Now they realize that's not enough, and so they extended it to 17. But if you're out in a 17, yeah, you're blowing off the planet. So I've got one in here that goes up to 7, which is about the point where you're starting to, it's hard to walk in the wind, and you're about this point. After this point, branches are breaking off trees, and so it's got kind of at the lower end of the Beaufort wind scale. Another thing that I've got in here is for estimating numbers. What does 1,000 look like? What does 500 look like? 100, 50, 10. So these are just to kind of help you when you're estimating numbers, how many geese are out there in the field, how many birds are in that flock. this is a useful thing for just kind of recalibrating your mental, what does 100 look like? Otherwise, what happens, people look at this and they say, oh, that looks like 100 to me. This looks like less than 100, doesn't it? That shouldn't be 100, but count them up, and it is. Another thing that is useful is percent cover. So I've got made a little, I made this series of dots getting increasingly clouded over. And the amount of black here is 10%, this is 90%, and this is everything. So if you're saying the sky is 50% cloud cover, what does that look like? The rock is 70% covered with lichen. The hillside is 80% chamise and 20% grassland. So if you're looking at that hillside from across the valley, you'd be kind of going like, yeah, it's kind of closer to that. Those are some neat numbers. And so I put those in there. One other thing that I've got is, this is a scale of gray, a gray scale. If you're ever wanting to know like what percent dark something is, this is that a scale that you can do that on. So those are just a few ways, tools that people can put into their journal or to carry with them that I found as useful quantification things. A really fun math exercise, by the way, is to go out with your students and do the PACE thing together. And then, you're going between, if you know the distance and you know the number of steps that it took, then you're asking them, what math equation do we do to find our meters per step? What math equation do we do to find our steps per meter? And then it becomes a really interesting conversation about those things. So those are just, I wanted to get us started with a few quantification tools. And let's first find out if anybody has, let's just start with some tools here. Are there any other quantification tools that people are aware of that would be useful to us as nature journalers that then let me know, because I want to, a bunch of these I've made like rulers and percent cover stickers and things that you can print out and put in your journal. Those are also, I've got them, if you go to my store, you can find things that will print out onto Avery labels that you can then take that sticker and put that percent cover thing in your journal. I also have copies of this back page here. If you want to just print out that quantification sheet with all those things, you don't want them on separate pages, stickers, you can print out that whole thing as a unit and stick that into the back of your journal. So those are kind of quantification hacks that I found useful. So are there any other quantification tools that people are aware of?
Jack. Hey, Jack.
Yes.
It's Brian. What about simple distributions? Like, are ducks randomly distributed on a pond? Are geese, do they cluster? Are trees, do they grow because wind randomly distributes them in an area? How can we think about a couple simple tools like that that help us think about the location and why something that, why we tend to see certain things in certain places?
That's a really good thought. You're trying to get people to look at patterns. You're trying to see are things clustered? Are things and what's interesting about that is if you just sprinkle things out randomly, randomness is clumpy. So in random distributions of things, there will be little places where things kind of get into clumps. And that it's really counterintuitive. Um, people think that if something is random, it's going to be, you know, heads, tails, heads, tails, heads, heads, tails, heads, tails, 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 heads, tails, like that. But if you start flipping a coin, you're going to eventually kind of get to these points where you're going tails, 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 right? And so those are just random clumps that come up in that. As a matter of fact, when I was a grad student at the University of Montana, we'd have students go out and collect data on things. And some of the students were really lazy and they would just make up their data set. And you can sit down and you could pick out all the ones where people had made up their data set because they look the way we think randomness is supposed to look. And people feel really uncomfortable making up a streak. So there'd be these data sets completely without streaks. And then you'd look harder and there'd be all these other things that you'd feel like, yep, these people are fudging it. And that was really fun. So yeah, how can you spot when you're out there in the field looking for patterns? How are things clustered? Looking at patterns is one of the next generation's science standards cross-cutting concepts. And so when you're doing things, analyzing patterns, you are right in there with what the NGSS is saying we should be doing with those, with kind of helping people think scientifically. A general approach to it is when I go out in the field, I say to myself, and I've done this with students, I will ask people, is there a pattern here? Can you find a pattern? And it's a great open-ended question. Is there a pattern here? And then people go out and they're looking for the patterns. And it turns out that human minds are pattern finding machines. We are predisposed to identify patterns, even when those patterns are not there, right? So if something happens 3 times in a row, boom, we've got a pattern. And we then are convinced that that's a real pattern. And so the next step in it is to intentionally find exceptions to the pattern. Can you find exceptions to the pattern? So you first are trying to find a pattern, then you're trying to find where are the exceptions to the pattern. And when you intentionally look for those exceptions to the pattern, if you don't find them when you're intentionally, deliberately looking for them, then that's really interesting, right? Or sometimes the places where you do find those exceptions are also really telling. But if you find lots of exceptions when you're looking for those exceptions, then you realize, oh, this actually isn't a pattern. That was my brain creating a pattern. So again, we have what's called a hypersensitive pattern recognition system in our brains. And this probably has an evolutionary advantage. Our ancestors who associate rustle in the bushes with tiger and climbed up a tree, they're the ones that passed on their genes. And ones who went like, this could just be random noise in the environment, right? Randomness is clumpy, and there's probably nothing to that. The ones who weren't, so if you jump at the rustle and see a pattern where there isn't one, you're probably going to survive better than the one who is not jumping at patterns. So the result is that we tend to see patterns where there aren't ones. We can see faces in clouds, and we'll find relationships in random noise. And so that's part of what we're doing when we are trying to find evidence against that pattern once you think you see it. That's a big part of what we're doing. Did that address what you were saying?
Yeah, certainly. I think that was very good. The application of, where's the pattern, I think is very helpful. Just cataloging where things are. It's nice. I think it's nice if you're intimidated with drawing 500 geese that you see or something like that, where there's a big quantity of them. You can start to diagram and say, I see the geese here, and the mallards that are, hunting in a different area seem to be grouped in this region, and then, start approaching it that way is another helpful.
Yeah, and that can be done with a graph. That can be done with just writing in numbers. That is a great. Does anybody else have other thoughts? Let's sort of play with this sort of patterns idea. Other thoughts and extensions on that. Aisha, yes.
I did something with the manzanita bush at school, where I suddenly had a bunch of helpers and I had no idea how many flowers in each cluster. And I just kind of almost assigned that task, pick a cluster and count how many flowers. And then we came back and we discovered a range, but the range had a thing and we could have gone into averages. And it was just also slowing everybody down to observe a little bit that the manzanita was in bloom, but I was toying with some math there. Wanted to share that.
That's good, and also it's neat that you're getting. So were they all looking at the same phenomenon, trying to get like how many in this cluster?
So everybody had their own cluster from the giant manzanita in bloom, and we did end up finding that it pretty much everybody their cluster was between 20 and 25 flowers on this species of manzanita, which was interesting. Like even I had no idea.
That's nice. And what's also kind of a fun extension on that is that if everybody is counting the same thing and keeps it a secret what their number is, you're gonna count it, you're gonna count it, you're gonna count it, you're gonna count it. We're all gonna keep it a secret, and then somebody compiles those. You can look at you get all sorts of different estimates for this same thing, right? And then you can start to look into, then you've got ideas of like what does sampling error look like? And if we're guessing on how many bush berries in this little cluster, how many grapes in this cluster of grapes, right? That's a really interesting exercise. It's interesting for one person, but it becomes absolutely fascinating when you get a group of people to do it, and then you can look at the distribution of those results. So Chris, could I pull you in to share some of the thoughts that you're thinking? Yeah, thank you for those thoughts on the manzanita. I really like that. You're muted.
Unmute. I was just thinking of all the ways that you can discover the compass directions, tell what's north, south, east, west, and noticing I've this isn't from teaching, but many times I've out sailing have tried to figure out the direction of the wind exactly. And then when you get in the woods, it's the same thing. And there are many it's quantitative only in understanding where you are in the compass rose, but it's a good idea to show the different ways that you can tell north, especially when you're hiking. That was my only thought. And also identifying or quantifying sound and trying to be able to tell how far it is from you. That's something that I don't know a lot about, but I've tried to work on. So yeah. Anyway, those are some kind of things. I know I've raced a lot in sailboats, and there's also a lot of ways to tell not only the wind direction, but how strong it's blowing.
Yeah, the Beaufort wind scale is a wonderful way of was developed by Beaufort, who was originally a captain and then became an admiral in the British Navy.
Right.
It was a system to figure out how high to raise your sails
Right.
for different wind speeds. And it's all based on, like, is there foam blowing off the tops of whitecaps?
Yeah.
Or is
Yep.
it forming streaks across the surface? And each one of these would have a different, at those different stages, you should do different things with which sails were up or down. That's
Right.
now been adapted for the land. And so where it's, you know, are whole branches moving or just leaves? And so that's a cool thing for describing wind direction. If wind is coming from the north and going to the south, you could describe that as a north wind, or you could describe that as a south wind. But there's a sort of in meteorology, the standard is that you describe it as the direction that the wind is blowing from. So a north wind is blowing from the north. So when you're standing with the wind blowing in your face, you're facing north, as opposed to it blowing to the north. So that is kind of a convention in describing those wind directions.
Right. So there are a lot of cultural things that aren't measurable too, in how the water is described. When you see, I know in Mexico there was certain gales were wild horses. It just depends on what you see in the waves. You know, a cotton patch. That was in New Zealand, I think. If it's really, really a lot of white, it just depends. You know, but it's kind of fun.
I like those colloquial descriptions.
Colloquially describing them, yes. And also I remember just looking at flags, smoke, and then you can also just have kids take old cassette tape, you know, and that is very light and reacts quite well to wind, and let them find different ways to feel the wind. Even that crazy thing of licking your finger on all sides and holding it up and see which side is cold. You know, even if there's, you know, anyway, there's a lot of different things around that I think are not necessarily quantitative, but they are part of that realm.
That's cool. Thank you, Chris. It's also great to hear from a sailor about the techniques that you have.
I've been out in 8.
An 8?
Yes.
Yeah. Okay. So eight is so you've got branches blowing off trees on the land at this point.
Yeah. But in the water, it's
you better be heading for port there, Chris. So Billy Joe, could I get you to talk to us a little bit about some biometrics?
Yeah, so I put a couple things into the chat. So in up here in Canada, we don't. So we are on centimeters and millimeters always, but the younger kids don't use. Yeah, we don't use inches and feet. So the kids learn right away how to do centimeters and millimeters and kilometers and meters and stuff. So, but when they're in kindergarten and a little bit into grade 1, they use non-standard units of measures before they sort of get into the centimeters and meters. So the end of your pinky finger is actually about the same length of 1 centimeter. So if you're an adult, if you put it in there, it's pretty close. If you have big man hands, it might be more than that. And if you're a little kid, if they kind of smush it a little bit, it's about 1 centimeter. So that's a nice way of using a non-standard unit. Is it pretty close, Jack? Pretty close for you?
Yeah, I'm about 1.5 centimeters for my my pinky.
Okay, so my pinky is 1 centimeter. So even if you were able to do that, so the tip of my finger is 1 centimeter. So that's kind of funner. They can measure it. I always ask them, like, is it bigger or smaller than your hand? So being able to sort of do that. And then the other part to add in for weather is that we get wind chills here in Ontario. So the other part of that is that yesterday here it was -14 was the actual temperature, but it felt like -21. So all you people living in California just love the sun right now.
We
And
don't
we
have
are
it.
in, yeah, we're in degrees Celsius, so I know that's different than Fahrenheit as well. So I'm not sure what the switchover is, but it's interesting to talk about. Even in the sun, it's super sunny outside, but what's that sort of correlation in terms of the numbers that you can get into wind speeds and how that affects your temperature as well, which is really fun when talking about that as well. So that's a great piece to bring in. And almost every day on our daily temperatures, they'll tell you what the temperature is and then what it feels like, because sometimes we can have it's minus 20, but it actually feels like minus 35 because of the wind chill. So you have those big variations between that, which is really nice. So those are just a couple of quick things that I've learned, just with working with some of the little kids. But I have to leave. I have to go to a staff meeting, but I'm going to watch the end of this at the end. So thank you so much for having me again, and I will see
Really,
you
Joe,
guys.
good to see you.
Yeah, you too. Bye, everyone.
Thank you so much. So just to riff on what Billy Joe was thinking about there, sort of another standard unit of temperature is what
Agreed.
are people wearing to what is the appropriate clothing for in a response to how it feels outside. And you can have a little sketch of a little cartoon character wearing shorts or bundled up in a million different things or holding an umbrella. So that is also kind of a non-standard way of describing temperature, is what are people wearing in response to what it is outside. Let's see here. What other thoughts on ways? So we've got, these are our tools. We've now got a toolkit of ways that we can get sort of see numbers around us. And by the way, the more you practice looking for numbers, the better you'll get at noticing, oh, there are numbers here. I can record those. A good kind of a procedure that I will often do when I've finished a nature journal page is I'll say to myself, words, pictures, numbers. And I'll look down, do I have words? Do I have pictures? Do I have numbers? I also do the same thing with I notice, I wonder, it reminds me of. I say, I've got my observations, I've got some questions. Oh, I didn't do it reminds me of. So I'm gonna see if I can pull out some of those. But very often I'll also find like, I didn't record any numbers, right? And then I'll look around and say, where are the numbers here that I could record? And once it becomes habit, it becomes habit. But until that time, you want to just sort of prompt yourself to see if you can harvest some numbers. So we've just explored some tools to find those numbers. Now, what are some things that you can do with them? Aisha, do you want to talk to folks a little bit about ratios?
Sure, because I would love some commentary back. This group is making me really push what I'm doing with my students. So I only came up with this because of your group, Jack. Thank you. And I knew we would have math one of these days. And I was like, what am I going to do? What am I going to do? So I was thinking is we've been growing garlic as a bulb as part of our plant reproduction unit. And I have a few sacrificial lambs that I periodically pull out of the ground that are not a student's own, but they're mine. Yep. And I was thinking we'd pull them out, use them as a nature journaling exercise, but I might do a prediction beforehand, but then introduce a way to use numbers, which would be measure the above ground versus the below ground part, the part we can't see, and see where they can take it with ratios. That because nobody knows if the roots are going to be longer or the top part's going to be longer. It's still at a sort of sprout level, and sort of learn from the kids where is possible to go with that.
That sounds like fun.
Or even the longest root compared to the shortest root on the same bulb, something with that.
Yeah. Let me grab a journal where I was actually measuring some things on plants. What you're saying reminds me of there you go. Let me jump to so this was a onion that sprouted in my pantry, and distance number one was the distance between the base of the onion and sort of the top of the sort of where this sort of green sprout thing came out. Distance number two was from the top of this sort of sprout part to the edge of the leaf. And so here's, got, alpha and delta here, right? So here are my, on different dates, my measurements in millimeters for alpha, the height of this thing, and delta here, the height of this. And then I graphed those, and what I saw was that at the start they were both growing, and then the upper part flattened off, but this lower part continued to push up and grow. I thought that was really interesting. This also could be something that you could be able to kind of harvest for playing with ratios as well.
Very nice. I love the graphing idea too. Do you mind showing the graph a little better?
Sure.
Graph and multiple dates on the same item. Nice.
So, yeah, so I've got millimeters, and out this way, I've got dates.
Wonderful. I can imagine applying that to a sprouting, the new branches and blossoms that are starting to show up on plants.
Yes, yes, yes.
Lengthening of twigs and.
I'm doing a similar thing right now. This was a little buckeye sprout that started. And then I got distracted and looked back at it. The next time I looked at it, it had this big crazy thing sticking out of it. And I wish that I had the wherewithal to measure it here, right? Because the next time I saw it, it was bigger. So then I started putting in my measurements, right? And so is this part here going to be continuing to grow, or is the growth going to be from this point up? Because here, if you look at it, this part here I didn't have it measured, but it appears that the length of this has not gotten bigger. But the point from this node here up has grown. So just yesterday, I did it again, and sure enough, this bottom part has stopped growing up, and this part up here is now growing. So I'm going to be able to, because I have these measurements in here, I will be able to graph the growth of these different sections. What I'm doing is I'm thinking about it in terms of the nodes. How much growth is there in this node versus this node versus, this next node? And that, I think it's going to be sort of I would also be able to graph that. Is that kind of on point with what you're looking at, Aisha?
Totally, and it's given me a bunch of more ideas, so thank you so much.
Right. Well, and check this out. The root is not growing. The root stopped growing. So this was 35 centimeters on the 29th, and then on the 2nd, 35 centimeters, millimeters. Kind of crazy.
That is kind of crazy. And so opposite of an acorn, which seems like it all happens in the roots before it happens above ground.
Yes, yeah, the acorns go crazy with that little root. Where are my? Well, I guess it's in a different journal. Yes, acorns go crazy on that root. I've got something where I'm tracking acorns, and I've now transplanted them to little cups, little Dixie cups, where I can no longer see the part that's underground, and I'm now just tracking the part above ground. But I'm not sure. Oh, it's not in this journal.
Thank you.
Absolutely. Other thoughts, ideas, connections?
This is Amy. What about like proportions of things? Like especially, for example, last Sunday at Melinda's Monterey Bay Nature Journaling Club, we were looking at albatrosses, and to warm up, we were just doing some 1-minute sketches or 30-second sketches of birds of all sorts of, and when we came on a kingfisher, we were looking at the proportion of their beak to their head, and I was like, my goodness, it's the same. Whereas all the other birds had like little bitty short beaks compared to their head. So that was really neat. So looking at proportions of things when you're drawing them or observing them is really neat.
And that also ties into drawing them, but not usually when I think about proportions, I'm thinking about that in terms of how do I get the proportions to be right in my picture, but also then to be recording those proportions mathematically. And Aisha, you could get even your ratios in there as well. Proportion of bill length to head length.
Definitely. Great place for ratios.
That's cool. I like that, Amy.
Thanks.
Let's see, folks. What about? All right, I'm gonna open up a great big old can of worms here. All right. What I think that probably the #1 missing piece in mathematical education, at least in the United States, is a fundamental understanding of statistics and the behavior of numbers when there are groups of things. And everybody sort of like makes the jokes that are like, there are lies, damn lies in statistics, or there's things about like, with statistics you can prove anything, which is using the wrong word proof wrong. With bad statistics, you can misrepresent lots of things, but this is why we want to become statistically savvy. Because statistics are really useful ways for thinking about things that are outside of the way that, like, our brains are set up to respond to story, right? So if I tell you a story about my cousin Mel and how he had one of those Subaru Outbacks, and let me tell you what happened to Mel, right? And that will sink into people's heads. And if I show you data on across, car types, these ones actually are, here are the stats on sort of, survival in crashes and these sorts of things. The numbers, we don't have ways of really, that doesn't stick in our heads the same way a story with a sample size of 1 will stick in our heads. So how can we start to incorporate now? And I think also that when we are taught statistics, unfortunately, rather than thinking with the numbers, we spend all our time first teaching people how to calculate the mean and the standard deviation. And so people are there kind of calculating the standard deviation by hand, right? Instead of thinking generally about like, here's a group of numbers, right? And what is the pattern here? What can we meaningfully say about this pattern? Ideas of what is the central tendency of the data? What is the spread and distribution of the data? Brian was talking earlier about, is this random or is there some sort of structure to it? So I want to open up this subject with you as scientists and nature journalists and educators. How might we be able to bring some of those things into our play with numbers?
So what if, this is Laura, what if you wanted to do something with seed distribution for like maple, Samara, and see if you could do something, by counting how many or taking a sample in different directions around the tree, or different distance. I mean, distances would be more complicated because I think that would require calculus, but, but at the same distance, but different directions, I mean, and that you could actually, hey, is that related to which way the wind's blowing? Kind of thing, something like that. I'm just thinking those kind of particular, any big seed, right? Little seeds aren't going to work, or even, but tying. So here's something my students noticed last semester was that when the trees were changing color, somebody noticed that they change at the top before the bottom. And that's because they just built, over 10-story apartment buildings in the area. And so her apartment was from the top of the tree, and then she went down and she looked at the bottom of the tree. The bottom of the tree, it still looked green. Top of the tree, is already turning colors. And then that set us off to start trying to observe and count. So anytime, right, if we have count distribution, you could do it by type, or you could just, is there, does the height of the tree matter? Do really short trees have that big a difference? I mean, there's all sorts of things you could ask. But I think, right, the statistics stuff is going to start with counting, or, classifying, putting things into categories and finding numbers for different things.
So
go back, that's fine.
I like your what you're thinking about. I just want to riff off of your idea about those leaves from the samaras drifting down from the tree.
You could do leaves too.
And so what I did is I've made myself a little compass rose here. And this is in the middle is my tree. Here's to the north of the tree, to the south of the tree, to the east of the tree, and to the west of the tree. Where I am, the prevailing wind is a westerly wind. So it's blowing from this direction to this direction. It would be interesting to just sort of take a swath of measurements in each of these directions and look at how far do we find, what are the distances that these seeds land, or maybe kind of get in there on day one and rake all the seeds away from the tree.
Mm-hmm.
And then come back the next day and look at, in this zone, you know, where are you finding these seeds? So in the north here, you're looking at the distance, and then in the east here, you would look at the distances of those. You would get different distributions, and these
Mm-hmm.
ones here would be all kind of in here. They would be something like this. So you could, you know, if you know, and then this would make an interesting pattern. I think you'd probably see something like that, sort of things being skewed towards close to the tree here, things being skewed towards further away from the tree here, and neither of those, and things sort of just being more of a normal distribution here and here.
Yep. And if you have the grounds fairly similar all the way around, like we have a lot of seedlings in, you know, when things pop up, you could do something even similar, or even if you don't have similar ground, what somehow a proportion with, I don't know, somehow get the number with that of seedlings you find in the same quadrants. I'm wondering whether.
So you're wondering if you're
I'm
finding.
wondering whether tree, you know, do trees move? I know trees move generation to generation. Do they move to the east? Do they move? I mean, do they move north? I mean, that kind of thing. I mean, it just, you wouldn't. I mean, you're not going to live long enough to know that, but maybe you could figure some things out by doing looking at where you get new
More
seedlings.
of a drift downwind
Mm-hmm.
of these seedlings than upwind.
And it would be different for acorn because they're not, you know, they're not distributed by wind.
You'd expect seedlings to be distributed relative to the direction of the wind on wind distributed things, and on things like the oaks, there wouldn't be a pattern like that. That'd be fun to look at. Let me show folks. Let me show folks one tool that I find really useful for collecting data in the field. If you already are familiar with stem leaf plots, you are happy. If this is new to you, this I found to be just a really game-changing thing to include in my nature journal. This is the structure of a stem leaf plot. Let's say I was recording how many decimeters the leaves are from the base of the tree. Right? And the first one, I find it at 30 decimeters away from the base of the tree. This first column over here is my tens place. This one over here is my ones place. The next one is going to be 55 decimeters away from the tree. And so I am going to put in my 55 here. And the next one is 73. And the next one is 62. And the next one is 52. See what I did? I already have my 50s going. I just added a 2 on here. And the next one is 47. And the next one is 59. And the next one is 63. And the next one is 67. And the next one is 91. And the next one is 54. And the next one is 41. So you see how I'm adding these up? I'm keeping these rows vertical above each other and keeping them this way sort of by 10. So my 8s would be in here. I just haven't gotten any 8s yet. When I collect my data this way, instead of in a table, it draws a picture of my data.
Mm-hmm.
So imagine this as being essentially a stem, a histogram, right, of my data, and I've collected that by just I've got my tens placed here, and then my ones I'm keeping track of them out to the side. And let's say this was to the east of the tree. I can actually do a comparison to the west of the tree. And if I measure distances out there, let's say the first one is 27. So I'm keeping my tens here. Now I'm just putting, instead of the 7 over here, I'm putting it over on this other side. So the next one is 11. The next one is 34. The next one is 5. The next one is 24. The next one is 13. And the next one is 21. The next one is 34. The next one is 62. Ooh, an outlier. The next one is 28. I can now do a comparison of these means. Or not the means, I can do a comparison of the distribution of these. And without having to calculate the mean and the standard deviation, I can get a sense of the shape of the data. So I have a sense that the central tendency of this thing here is somewhere around here. And the central tendency of this one is somewhere around here. And the spread of this is like that. And the spread of this one is like that. So I get a sense of, by looking at the picture, I don't have to calculate my mean and my standard deviation. I've got a sense of where the middle of this data is and the spread of it. It's a crazy useful tool. I found a couple of classrooms where they teach this, usually at around 5th grade level. And then it seems to be forgotten and never picked up again. But I think that stem leaf plots, these are called stem leaf plots. It's the stem down the middle, these are the leaves out on the sides. Stem leaf plots are absolutely brilliant tools for engaging with with sampling, collecting numbers, because your sample draws its own picture instead of instead of just being a table of numbers. And you look at the table of numbers and you think, I think I should calculate a mean and a standard deviation, but I don't think I ever will. Any thoughts, comments, or ideas?
I am doing the practice with the percent coverages that I was mentioning earlier. Melinda had given me this really great idea because sometimes 20% can look different depending on where all of the things are. And so she told me to get a box and cover it with marbles on the bottom, and then take out certain percentages of the marbles and practice seeing how it looks different. So this is 20% of the marbles, and then you shake it, and then 20% looks a little bit different, or perhaps it looks like this. And so you can kind of get an idea of the different ways that the percent coverages can look, just for fun. So that's 20%. That is also 20%. And that is 20% as well, just for fun.
I think that is absolutely brilliant. I think that is absolutely brilliant. It takes that idea of, just that little circle with the little dots in it to the next level, because the way you think about those 20% are different if they're spread out versus if they're in a big clump.
Yeah, I have Melinda to thank for that. So I'm going to be practicing with that and possibly drawing to see what the different clumps look like, so I can get different ideas of what 20% looks like. Make it easier maybe for estimating birds or covers like when the leaves fall or whatever else. It'll be fun.
This kind of this physical model and kind of guessing it and kind of shaking up your mental Etch-a-Sketch reminds me of being in Montana with a few people who are doing wildlife research. And in the evenings, what they would do to kind of sharpen their skills is they had this dark blanket and some white beans, and they would take, one of them would count out a known quantity of white beans and toss them out on the rug. And what everybody had to do was to look down, glance at it, kind of get a spot sense of what that number was, and then they would kind of group count them, like, okay, that's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 100, 200, 300, 400. That's 450, right? And then they would be told by the person who actually had counted the beans how many beans that was. And so they were trying to get their intuitive sense of numbers to be more accurate with a process with feedback. I really like what you've got, because it's also just this, along the same lines, this physical model that that gets you to visualize these numbers in different ways.
Do you want to? Oh, thank you. Do you want to take a guess of how many marbles there are in it?
Oh yeah, actually, I'm going to ask everybody to guess. All right, actually, everybody just take a quick guess, and so everybody write down that guess that you have. All right. Now what I'm going to ask you to do is to count by count 5, and then get yourself 10, and count these by tens and see if you get a different number.
I'll try to hold it still, but nature moves, so this could be a simulation.
All right. Now, what we're all going to do is, in the chat, everybody is going to type in 2 numbers. The first number will be your first guess. And by the way, you're not going to change your numbers based on the things that anybody else got, right? The first number will be your first guess of what it was when you kind of took the quick glance at it. And then your second number is going to be when you kind of group counted by tens. Right, and when I say go, we're all going to hit return on your computers, and we're going to see what we got. And interestingly enough, if somebody at this point said out loud any number, it would bias your thinking. Even if it was obviously an absurd number. If it was an absurdly low number, you would anchor lower because of that. If it was an absurdly high number, you would anchor high because of that. If I had a roulette wheel here and I spun it and it ended up on a high number, that would bias everybody's thinking towards higher numbers, even though you know that there is no relationship to it. That's how easily we are anchored. So be careful of anchoring on a number. Does everybody have your numbers ready? And I'm going to ask everybody, let's post them. All right. Now, Ivea, do you know the number?
Yes,
Tell us.
the number is
Wait, hold on. Before you do, anybody watching this at home, you have to have done the same thing, right? I hope you did. Okay, here we go.
the number is 68.
68.
Mm-hmm.
That's cool. So so notice if you were an overcounter or an undercounter, right? And that is really interesting. And now we'll look back through this. Now, wouldn't it be interesting if we regularly practice this to make a stem leaf plot of everybody's responses and track those over time, looking at two things. One would be is if over time the spread of our estimations gets closer together. That is, that we're becoming more precise in our estimations. And does the central tendency of that data, the mean or the median of that data, are our estimates getting closer to where it actually is? So are we starting off generally overestimating, and then over time we're bringing it in there? Wouldn't that be fascinating to see? Right? So this is just an example of a way that you could teach numeracy in your class. Right? You start doing this, you would be teaching people about the spread of data, and then also the the central tendency of data, and we would be looking at that changing through time, and we'd have predictions about how that would look. I think that would be really, really fascinating. And what also is kind of cool about this is that you'd be looking at real numbers. Hey, that was really fun. That was really fun. I think that at the next Wild Wonder, we should have a numerical geek out evening where we kind of get people together and like we're throwing beans on the floor and doing some of these sorts of puzzles. I think that'd be a ton of fun. All right, everybody. Are there, we're a little bit over our time here, but just want to check in and see if there are any other comments, ideas, thoughts that people wanted to share. Yeah, and Anne, yes, next time when we do this live in person, let's have have numerical prizes, prizes for these things. We'll motivate ourselves. Some extrinsic motivation, but also just to extend a chance to kind of exchange some gifts.
Jack, my question is, well, actually, my thing that you were talking about patterns. One of the things I've always observed every year is the robins coming through. We have cherry laurel trees in our neighbor's yard, and they come in, they settle on our pine trees and our deck and our trampoline, and they leave everything behind. And I got frustrated, and I'd get out and hose it down, and they would just keep on coming and eating, and just more and more everywhere. It was just terrible. And then all of a sudden I started noticing a pattern, because it seems like my robins come through, and then we have this real, if I wait long enough, there's a heavy rainstorm that comes through and washes everything away, and spring comes. And so I was thinking in terms of, like, when you see birds coming through and seeing a pattern of when do you see, how long after the birds do you see rainstorms, or how long after the birds do you really see spring, you know, the blooming and all that other stuff.
That's a really great thought. So you've observed a pattern, and here the tendency, the tendency for us is to like, if you were told by somebody, when you see the robins, in 2 weeks spring will come, then what would happen is your brain would kind of associate spring with whatever is going on in 2 weeks, right? And or when you kind of see, like, oh, it looks like spring is here, then you're like, yeah, it was about 2 weeks ago that the robins appeared. And that's why kind of keeping records is really, really important, because we will tend to, like, adjust our memories of experiences to fit whatever data we think it's supposed to fit. So if you start recording, like, start looking for the first robins, or a way of doing that might be by measuring the number of robin poops on the trampoline. If you wash it once a week, right? Number of robin poops on the trampoline, number of robin poops on the trampoline, number of robin poops on the trampoline. Then record in there where you're getting, here we're using the number of robin poops on the trampoline as an indicator of general robin numbers, right? And then record when you get your rainstorms, and you'd have to figure out, you know, what you're using to define spring. Maybe it's your first narcissus blooming or whatever it is. Whatever for you the sign of spring is. But that would be really fun. That would be really fun to do. But the secret is going to be in record keeping, because otherwise we backwards kind of remember things to fit whatever pattern we think we're supposed to see.
Yeah, what they do is they come in a huge swarm all at once. They descend, and they're everywhere. I mean, they're just on the pine trees. They're on. Now we've cut down some of our pine trees, and the trampoline is no longer there. But they used to, and I tried even putting an owl up, because they because they come in like this huge flock. They're just like a cloud. And they descend on these, and now my neighbor has cut down his cherry laurel, so I expect to see, there's still one left, but I'd expect to see a lot less of them. But yeah, they come in this huge flock, and they used to come in and just spend about a couple days there. Since we got, like, the cherry laurels cut down, now we got even more cherry laurels cut down. When he cut down the first few, we started seeing they more straggle in, rather than in this huge cloud. I mean, I know it's not thousands, but it seemed like thousands of them. They just were like a horde.
Yeah, you're saying that there's this robin pulse that comes through.
Right.
I think that to kind of get out there before the robin pulse, and just kind of to kind of get measurements of, like, on typical day, I'm seeing this many, I'm seeing this many, I'm seeing this many. And in that kind of window where you're expecting that robin pulse to come through, really watch for it and wait for it, and record. When you get out there, you don't have to get exactly how many, but if you get out there and you kind of go like, on that tree, that's about 20. So then a 20, 30, 40, 50, that's 100, 5, maybe 200 robins, right? And before it was 2. So you'd be able to get that. It'd be interesting to record that over time, see how long that robin pulse is, and how that changes from year to year, or is it in the same time? What you're talking about here is the science of phenology. So phenology is how plant blooming and bird migration, sort of natural events, are related to what is going on the calendar and the climate. And what we're finding is that different sorts of organisms respond to different things. Some animals, their responses are based on essentially the calendar, and they're looking at the position of the sun to for like, oh, it's now time to go do this. Others are responding to warmth and heat or melt of snowpack. And so different sorts of organisms, some of them, we're seeing these big changes as the climate is warming and things are getting hotter earlier. We're seeing the birds responding exactly to that pattern, and other organisms aren't. So the problem, one problem with this is that if the birds are responding, say, to the temperature, and they're going like, hey, it's warm, let's go north. And the insects are on some kind of, internal biological clock. It used to be that the birds would arrive when the insects pop out. Now the birds, in some places in sort of northern breeding grounds, birds are arriving now before all the insects come out and hatch and are available as food sources for them. And it ain't good. So starting to watch the phenology and documenting that and recording it over time and the changes of that in your own area is really, really cool.
Okay, thank you so much.
Thank you. That's absolutely fascinating.
And I guess one thing to start watching is last year, it seemed like the robins were slower coming through, with them cutting down a number of the cherry laurels, and he cut down the biggest one this year. I have to say, I am not disappointed because that cherry laurel is so invasive. But I'm wondering if it's going to be slower them coming through this year in relation, because it seemed like they seem to kind of trickle through last year. I didn't have the huge pulse we had for years.
That I think starting to collect data on that would be absolutely fascinating.
Okay, thank you so much.
Thank you. Let me see here. I'm just going to see if I can find. So a way of looking at this would be fascinating. Would be with real-time data sets like what they get with eBird. I was just checking to see if eBird had an animation of the robin migration. They've created that for several species, and it's really beautiful. So we'll just pause for one moment and see if my slow internet. Oh yeah. Okay, this is gonna be cool. Yep. I'm going to screen share with you folks. And this will blow your mind. This is an animation that is made off of the data that is collected from people's eBird. When people have this little app where they go out and they go bird watching. They say, "Oh, I'm seeing these birds here." Check this out. I'm going to see if I can do my screen share here. Oh, this is some crazy. Hold on. Oh, I'm not screen sharing yet, am I? Sorry about that, everybody. Like, oh, look at this, but you can't. Wait for it. Wait for it. Are you seeing an eBird screen? A picture of a map?
Yes, we are.
You are. Okay. Look at this. So I'm going to actually jump back here. This is February, March, April, May, June, July, August, September, October, November, December, January, February, April, May, June. So what this is this is from real-time data of the concentration, sort of the migrations of robins over the course of a year. Isn't that mind-blowing? So when you are collecting that kind of data and looking at your own backyard, this is what we're seeing. Wow. It's beautiful, isn't it? And just think of, this is a direct result of the fact that the Earth is tilted on its axis. And if it weren't, you would not see this migration. Crazy, the connections between things. There we go. Actually, maybe to round this out, I would like to bring on Ann Chadwick from Point Blue Conservation Science to talk just a little bit about long-term data sets and kind of the sort of the ideas of what we're talking about here are actually being done on a larger scale by career scientists and researchers all over the world. And you work with a large team of these people. Maybe just tell us about that and we'll then call it a wrap for the day.
Great, thank you so much, Jack. Yeah, so I'm with Point Blue Conservation Science. And I'm on the board of directors, I'm the vice chair. And we've been around for 52 years and we have now 160 scientists on staff. And talk about phenology. Some of them have been there the whole time actually, and started as interns maybe at our Palo Marin Field Station, for example, which is north of San Francisco in California. We also have scientists out on the Farallon Islands, about 17 miles out from California, which is sort of like the Galapagos of California. We have scientists in Antarctica who have been studying Adelie penguins for over 25 years. But our data sets going back, like at Palo Marin, we have these journals, handwritten journals, that go back, I think, 52 years. And, looking at just what Jack's been talking about is how climate is affecting bird migrations and breeding success and their food and chaparral, their habitat, how that's affected, and how we might help, how we can use nature-based solutions to help give species more time to adjust, and also to communicate the importance of climate smart conservation. But we have just a lot of different projects going on around the world, actually. We work with scientists from different countries to, again, look at climate smart conservation. So we have a migratory bird project that involves, I think it's 16 countries all along the Pacific coast, from Alaska to Chile. And of course, then we do go into Antarctica with the penguins. So, and some of the work is doing things like creating marine protected areas, or doing marsh restoration, or using healthy soils to help combat climate change and so on. So, but we're really all about the data and the science. And I think I just took a distanced walk with our director of informatics, and I think we're managing over 1 billion data points now that include some of the backups for the US government, which were super important during the last administration when, the word climate meant, don't do that work. We're not going to talk about that, and we're going to delete data. So we had the backup data for that. We have data in coordination with the Cornell Lab of Ornithology, and with different organizations around the world. So we're all about evidence and science and evidence-based work to do what we can to help biodiversity and success of our planet. So thanks, Jack, for the forum.
Absolutely, and thank you for the research that you're doing. We're actually going to have some of Anne's scientists and researchers on some of our other workshops at points in the future, and be able to kind of touch bases on work that those folks are doing. So the stuff which you are modeling in classrooms when you're doing phenology stuff with your students, science activities like that are, I think, most effective when they're legitimate things. These are things that other professionals are doing all over the world to kind of get a handle on this. And you can be tracking these same sort of things if you start tracking, what's going on with the robins right in my backyard. That's really cool. And thank you, friends, all. Thank you so much. Also want to say thank you to Brian and Ivea for helping moderate this workshop. And I hope that everybody here got some ideas and strategies to help them use numbers more effectively in their nature journal.